grade, please get out Module 4, Lesson 7. This is actually the last lesson in Module 4. It starts on page 107. It is identify number patterns on the multiplication table. So we're going to be using the multiplication table to see if we can notice any patterns when we are multiplying. So when you are done, hopefully you'll be able to identify arithmetic patterns in the multiplication table and explain them by using the properties of operations. I can use patterns and properties to find products in a table and to identify products as odd or even. Now, when we're looking for odd or even numbers, how do we know if a number is odd or if a number is even? Well, we'll always look in the ones place, remember? So you always look in your ones place when we are determining odd or even. And if it is odd, in the ones place, you will have a 1, a 3, a 5, a 7, or a 9. If it is even, you will have a 2, a 4, 6, 8, or 0 in your ones place. So these are your ones places to be an even number, and these are your digits in the ones place that would make it an odd number. So I just wanted to give you a little refresher on that to remind you to have your brains remember. So pens are sold in packs of 1, 2, 3, 4, 5, or 6 pens. We can see the packages here. Ray wants to buy an even number of pens. If Ray buys 3 packs of pens with the same number of pens in each pack, which packs could give him an even number of pens? So he wants to buy an even number of pens, and he wants to buy 3 of them. And they're sold in packs of 1, 2, 3, 4, 5, or 6. So we need to multiply by 3 to find the answer, and then we're going to have to determine whether it's even or odd. So if I have 3 packs and there's only 1 pen in each pack, this is your identity property, right? So this would be 3 times 1. And 3 times 1, it's 1 group, or it's 3 groups, right? With 1 pen in each group. So that would give him how many pens? 3 pens. Is that an even or an odd number? That is an odd number, right? 1, 3, 5, 7, and 9 are all odd. Next we have 3 times 2. So we've got 3 packs with 2 in each pack. So we have 2, 4, 6 is our answer. Is 6 an odd or an even number? 6 is an even number. So he could buy 3 packs of 2, which would give him 6 pens, and that would give him an even number. What about 3 times 3? So we have our 3 packs, and there are 3 in each pack. So 3, 6, we have 9. Is 9 an even or an odd number? 9 is an odd number, so he's not going to want to buy packs of 3. 3 packs of 3 is odd. 3 times 4. So we have our 3 groups, and now each group has 4 in it. So 4, 8, 12. So remember, it's the ones place. So is the 2 in the ones place an odd or an even number? It's an even number, right? So 12 is even. We always look in the ones place. So 5 times 3, or 3 times 5 is our next number. So our 3 packages, and there are 5 in each package. 5, 10, 15. So again, I look in my ones place. I have a 5. Is my 5 even or odd? My 5 is odd. So 15 is an odd number. And last but not least, we have 3 times 6. So 3 packages with 6 in each package. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So 6, 12, 18. So I have 18 pens in with 3 packages of 6. Is our 8 even or odd? Our 8 is an even number. Remember, we look at the ones place. So to have an even number, what packages could he purchase? He could purchase 3 packages of 2. I'm gonna abbreviate packages. Another even one would give us 3 packages of 4. And he could also do 3 packages of 6. That would give him an even number. One thing I'm noticing for the number 3, anything times 3, if you multiply it by an even number, you're going to get an even number. If you multiply 3 by an odd number, you get an odd number. It's one thing I notice about my 3s. I wonder if that's true for all of them. We'll have to wait and see, but that definitely is true for our 3s. All right, 108. Build some understanding. So we have Nan, and she is here using patterns and multiplication properties to find products on a multiplication table. Nan uses the identity property to find the products 1 times 2 and 5 times 1. Use the identity property to find the other products. So notice she already found some of her 1s, right? So we're going to do 1 times 1 is 1. 1 times 0 is 0. 1 times 3 is 3. 1 times 4 is 4. 1 times 5, she already did, is 5. 1 times 6 is 6. 1 times 7 is 7. 1 times 8 is 8. 1 times 9 is 9. And 1 times 10 is 10. So there's our identity property across our chart. We also could do the identity property going in this direction. 1 times 0 is 1. 1 times 1 is 1. 1 times 2 is 2. 1 times 3 is 3. 1 times 4 is 4. 1 times 5 is 5. 1 times 6 is 6. 1 times 7 is 7. 1 times 8 is 8. 1 times 9 is 9. And 1 times 10 is 10. So that fills in our identity property. Notice these are all of our 1s, and these are all of our 1s. The numbers on the side that are multiplied by 1, or the numbers across the top. Nan uses the 0 property to find the products 8 times 0 and 0 times 9. So we know for the 0 property, it's all going to be 0, right? Anything times 0 is 0. So this one is easy to fill out, right? Anything times 0 equals 0. So we can see all of these are zeros and all of those are zeros because anything times 0 is 0. Complete the columns for 3 and 4. All right, so let's see our column for 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. 3 times 5 is 15. 3 times 6 is 18. 3 times 7 is 21. 3 times 8 is 24. 3 times 9 is 27. 3 times 10 is 30. So now let's find our 3's, and we're going to now go across. So we've got 0, 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30. So there's our 3's. Now we're going to do our 4's. So 0, 4, 8, 12, 16, 20, 24, 28, 32, 36, and 40. So now we're going to go 4 across here. So we have 0, 4, 8, 12, and 16 are already filled in. So then I have 20, 24, 28, 32, 36, and 40. Now, to complete the products in the column for 7, it wants us to add the 2, the 3, and the 4 to get what goes in the 7, right? Because we can break apart our 3 and our 4, or break apart our 7 to be a 3 and a 4. So what is 8 plus 6? 8 plus 6 is 14. And we already have 21 and 28. So what's 20 plus 15? Well, 5 plus 0 is 5, and 2 plus 1 is 3, so 35. 18 plus 24. 8 plus 4 is 12. Regroup our 1, so we have a 42. 21 plus 28. Well, 8 plus 1 is 9, and 2 plus 2 is 4. 24 plus 32. 4 plus 2 is 6. 3 plus 2 is 5, so 56. 27 plus 36, 7 plus 6, 13. Regroup my 1, so it's 63. And then 40 plus 30 is 70. And now I'm going to go across with my 7's because I went down with my 7's. So 0, 7, 14. 21, 28 is already written in, so 35, 42, 49 is already written in, so 56, 63, and 70. So we've got quite a bit of our chart already filled out. So now let's look. Nan uses the commutative property to find the products 8 times 2 and 2 times 6. Well, I'm not going to worry about that. I'm going to go with my 2's. Let's count by 2's. 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So we've got 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Try to do the ones that we know, and then we can fill in the blanks. Let's do our 5's. 0, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. And go our 5's across. Look at, we have got most of this filled out. 0, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. How about we do our 10's? 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. 0, 10, 20, 30, 40, 50, 60, 70, 80, 90. And look at, now we just have a tiny little bit to figure out. Well, let's see, we've got 6 times 6. So we just need to add 6 to our 30, right? Because we're counting by sixes. So what's 30 plus 6? 30 plus 6 is 36. This one should be fairly easy too. Now this is, we're counting by eights. And I've got 40 here. What's 40 plus 8? 40 plus 8 is 48. And look, here's our nines. Let's do our nines. So if we're doing 9 times 6, what's 1 less than 6? 5. 5 plus what equals 9? 4. 9 plus 8. 1 less than 8 is 7. 7 plus what equals 9? 2. 9 plus 9. 1 less than 9 is 8. 8 plus what equals 9? 1. So and then we can finish filling out our nines. 54, 63, 72, and now we've got 2 left. Do we have these anywhere? 6 times 8. 6 times 8, ooh, 48. And then we've got 8 times 8. So if I add 8 to 56, 56 plus 8, 57, 58, 59, 60, 61, 62, 63, 64. And there is our completed chart. Oh my goodness, that takes a while. And we're going to skip letter E, because we kind of talked about our patterns while we were doing them. Okay, so page 109. JC wants to use patterns and multiplication properties on the multiplication table to see if products are even or odd. So we're going to be looking for even or odd. How can we help him? So we are going to choose an even factor as our first factor. And we're going to shade the row of products. So I'm going to use a highlighter so that way you'll still be able to see the number. So let's do an even row. So remember, rows are across. So let's look at our 2's. Notice if we have an even number, what happens to the number multiplied by a 2? All of our numbers are even. Let's look over here. Let's look at our 4, another even number. What do we notice about all of our numbers? All of our numbers are even. Look at 4 is even, 8 is even, the 2 in the 1's place is even, 6 is even, 0 is even, 4, 8, 2, 6, 0. Those are all even numbers. Let's look at our 6's. We have 6, 2, 8, 4, 0, 6, 2, 8, 4, 0. All even numbers. So if we multiply by an even number, our answer is going to be even. Okay? When you multiply by an even number, your answer is even. It will always, 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 always be even. Anytime you're multiplying by an even number, 2, 4, 6, 8, 10. Look at your answer. Will always be an even number. Okay? So that's what we are noticing. So now we're going to choose a column. It's the same, we just did A and B together. So it's going to be an even number. So don't worry about B. They're both the same. Now we're going to choose a column for a second factor that is odd. So this time we're going to do a column, an up and down one, that is odd. I'm going to do a different color so that way you can see the odd number with a different highlighter. So let's do 3. 3 is an odd number. So we're going to go down with our odd number. So when I multiply an odd number by an odd number, my answer is odd. But my multiply an odd number by an even number, it's going to be even because we just found out anything times an even number is even. So if it's odd multiplied by odd, it looks like you're going to get an odd number. Odd by odd is an odd number. 3 and 7 are odd, 21 is odd. 3 multiplied by 9 is odd, 27 is odd. Let's see if that stands with another odd number. Let's look at 7. Seven times 1, both are odd, you get 7. 7 times 3, both are odd, you get odd. So the only way to get an odd number is if you multiply odd by odd, and that will get you an odd number. So even by anything, anytime there's an even number, your answer will be even. The way to get an odd number is both numbers have to be odd. Okay? So that's going to be the difference with your even and your odd. So, Tanya and Lou each think they may have found a pattern. Does each person's statement make sense? When you multiply an even number and an odd number, the product is even. Well, we know she's right? Because she multiplied by an even number. Anytime you have an even number, your answer is going to be even. When you multiply an even number and an even number, the product is even. Well, he's right as well, Because as long as there's an even number, your answer is going to be even. So we're gonna prove this fact. So we're gonna break apart. We're gonna try 4 times 7. 4 is an even number, 7 is an odd number. And she's saying it's going to be an even number, which we've already proven it is even, but let's see. So we're going to break apart the array into 2 equal groups. We have 4 groups of 7, broke them apart into 2 different groups. So I broke apart my array into, this would be a 2 times a 7, and this part would be a 2 times a 7. Are there equal groups with no tiles left over? Yes. So the product is, what's 2 times 7? Oh, sorry, the product is, 2 times 7 is 14. 2 times 7 is 14. When I add 14 plus 14, I get 28. So is my answer even? Yes, my answer is even. So Taya's statement makes sense. Now we're going to look at Lou's statement. And he said even times an even equals an even. So we've got 2 is an even number, 8 is an even number. We're going to circle equal groups. So we got equal groups of 2. So I circled how many pairs? 1, 2, 3, 4, 5, 6, 7, 8 pairs of 2 tiles each. Are there equal groups with no tiles left over? Yes. If you had tiles left over, then that would be an odd number. So the product is even. If you have no tiles left over, then it's even. So his statement makes sense. So remember, anything times an even number equals an even number. Your answer has to be even if you're multiplying by an even number. Okay. 111. Tarek is using the identity property of multiplication to find 7 times 1. What is another multiplication fact you can find using the identity property? Well, we can just choose any, right? Any fact multiplied by 1. Could we do, let's say we do 5 times 1. What does 5 times 1 equal? 5. 5 groups of 1 is 5. So anything times 1 is itself. All right. Let's look at our problems. We are going to find out, is the product even or odd? And we're going to write even or odd. 3 times 3. 3 is an odd number. So I have 2 odd numbers multiplied together, so my answer will be odd. Remember, 2 odds make an odd. 6 times 9. 6 is even, 9 is odd. Anything multiplied by an even number will be even. It doesn't matter what the other number is. As long as you have one even number, your answer will be even. 2 times 8. Both of my numbers are even. So it for sure will be even. 5 times 7. Ooh, my 5 is odd and my 7 is odd. They both are odd numbers, so the answer must be an odd number. And 4 times 5. My 4 is my even number, 5 is odd, but as long as I have an even number, then my answer will be even. Good job. All right. So now it's on your own, but you can either work with me or do it independently and come back and check your answers. So we are using the multiplication table over here. We're going to complete the products in the row for the factors of 6. So 6 times 1 is 6. 6 times 2 is 12. 6 times 3 is 18. 6 times 4 is 24. 6 times 5 is 30. 6 times 6 is 36. 6 times 7 is 42. 6 times 8 is 48. 6 times 9 is 54. And 6 times 10 is 60. So what even or odd pattern do we see in the products? Well, we see that it is an even pattern, right? All the answers are even. So it is an even pattern because they're all even. To find 6 times 4, how can you break apart the factor 4 into equal addends to find the product? Well, couldn't we break apart our 4 into a 2 plus a 2? So I could do 6 times our 2 plus our 2, because I know that 2 plus 2 equals 4. And then I could multiply my 6 times my 2, and I would add it to another 6 plus 2. 6 times 2. 6 times 2. 6 times 2. I got ahead of myself. 6 times 2 equals, and we can even look at our chart, right? 6 times 2 is 12 plus 12, and 12 plus 12 equals 24. And I know I'm pretty sure I'm right, because at least I know I've got my even number, right? Because it's a 6, an even number. All right, we're going to write the unknown number. So 4 plus what? So what number? We kept our 6 on the outside of our parentheses, so that means we're breaking apart our 9. 9 broken apart would be 4 plus what? 4 plus 5. 7 times 8 equals 7 times, so I kept my 7 and I'm breaking apart my 8. 8 would be 2 plus what? 2 plus what equals 8? 2 plus 6 equals 8. And 112. Use the multiplication table, complete the products for the column for 7. So 7 times 1 is 7. 7 times 2 is 14. 7 times 3 is 21. 7 times 4 is 28. 7 times 5 is 35. 7 times 6 is 42. 7 times 7 is 49. 7 times 8 is 56. 7 times 9 is 63. And 7 times 10 is 70. So what we're noticing is that if your odd number is multiplied by an odd number, you're going to equal an odd number. Odd number by an even number is an even number. So odd times odd equals odd. And then odd times even equals even. Okay, we are going to skip number 12 and we're going to move on to our last few. Alrighty, 1 times 4, are we going to be even or odd? Well, my 4 is even, so I must be even. 3 times 7, they are both odd, so I must be odd. 6 times 6, they're both even, so I am even. 7 times 8, my 8 is even, so my answer will be even. 9 times 9, we're both odd, so my answer will be odd. Alrighty, so you are going to do Module 4.7, or Module 4, Lesson 7. So you're going to do 4.7 more practice / homework. I'm just going to look really quickly to see. I'm going to have you do everything on the front page and everything on the back page. All right, you are good to go. When you are finished, please send me copies of that work, and then I will grade them. All right, I hope you guys have a great rest of your week, and I will see you soon. Bye.